Hi guys, this is another video with regards with SAP 2000 and so today the problem is for the frame distributed and concentrated moments. So similar to the other video, this document has been provided by the SAP 2000 to show that the SAP 2000 is consistent with the hand calculations, but on this document they did not show how to do it in a sub 2000. So that's why on this video I will show you how. So basically, so let's start. So I will go, so file, new models. So I select inches because the unit is inches, so and then I select grid only. And then I will count the number of grid lines, which is 1 2 3 4 5. So I will type pipe here, 1 1, and then I will type 5 first, and then later on I'm going to change the grid line. Click OK. So I will close the 3D view, go to the XY plane, and then go to define coordinate system, modify, and then I will select spacing, and then I will modify the grid line. So it's supposed to be a 5212 spacing. So 5212, and then we are correct. And then this one. And then after that, I'm going to add the beam. This is, it will be a pipe shop. Call it. Oh, I forgot to mention the problem. The problem is a 1-inch diameter circular shaft fixed at one end and is loaded with the various type of torsional moments in two different load cases. So the resulting torsional reaction at the fixed end and the rotation of two joints along the shaft are compared with independent calculated result. So we have two load cases, and then so shall we just continue. So I said that the end will be fixed, so we click assign join restraint, and then we select the fixed connection, which is all the translation are checked and rotation are checked, and then we click OK. And after that we select all the members and click assign frame section, and then we click add new properties, and we select concrete for the meantime, and then we click the circular, and then it says that a 1-inch diameter circular shaft. So we are studying the shaft, so we call it 1, and then after that we click the plus sign, add new materials, we select steel, and now we select A36 and click OK, and then click modify, so just to double check that we are consistent with the units given. So so 28,909 28990, and then that's it. We click OK, so we are consistent. Click OK. So we select the A36 and click OK, and then we select the F2 and click OK. So now, so let me show you the labels for the joint and labels for the trim, and make sure that we are consistent. So let's go to the load case now. So load case, one keep inches per inches uniform distributed torsion on frame element 2. So these are the frame element 2, which is 1 keep inches per inches to here. So we just basically have to uh, to put that load. So we click this member, this is the member 2, and then click assign frame loads distributed. We click the plus sign, we add the load case, we call it load case number 1, and then we select the others and click add new load and click OK. So we select the load case, we select the moment, this moment, and we click local, and then it says 1 inch, so 1 keep inch, so click okay. So that's it. So uh, it says the the load on the 2 keep inch, it says that here the 2 keep inch torsion on the joint port end of frame object number 3. So this is the frame object number 3. Click assign frame loads point, click the load case number 1, click the moment local, and then 1, type 0 here, 0 here. So at the end it says 2 keeps, click OK, and then let's run to find out the answer for this one. Oops, I let me for the load patterns, no, for the load cases I don't want to see this dead end model, so I will click delete for the one and delete for the model and click OK. So I will run the model, run, and then I will save it. You can save it to any number, to any name, and then let's see the result. So first thing we have to compare our answer is for the load case number 1, the moment fx. So we have to see if our answer is same as given. So show the value and click the torsion and click OK. So yes, the moment is 4 and we are correct. So we have to find a joint 3. So joint 3 we have to go check this one and then click the load case. So select I can just click loop and then joint 3. Oh, that's the joint 3. So I will click right click. So the answer is 0.02375. So because of that load, torsion load, and the rotation is 0.02375, that is the answer we get. So we are consistent. So it's just 0.02, so we are correct. And then now I have to find out the 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 rotation for the joint number 5. So this is the joint number 5. So it's in the middle. So the rotation is 0.02558. So we are correct. So now let's do the I will click this one, and then let's do the load case for the number 2. I will try to rough it up. So load case number 1, we are done. So there is a triangular distributed torsion with a maximum value of 1.5. So I will select this one, click assign frame loads distributed. I will click the plus sign and I will put load case number 2 and click others, and then click add new load pattern and OK, and then click load case number 2, select moment, click local 1, and then I will place it 0 0 0, and I will place this 1 as say 1.5, and then click OK. So that's the loading. So 1.5, and then for the last member we click assign frame loads point. So we select load case number 2, moment local x 0 here 0 here, and then the value of should put 2 keeps torsion. So click 2 and click OK. Then we run the analysis. So load case 1 run, do not run for the number 1, and then run now, and then we check the maximum moment, click OK. So the answer is 5.75, and we are correct. And then for the joint 3, so we select this deform shape, and then control B joint, and then we are asked to find the rotation of joint 3. We right click this one, and then 0.2421, So we get the answer correctly, and then control B again, and then we select the joint pipe, and then we right click, and then